Looking at problem 101, it's a question where you have to identify ultrasonic phenomena using related keywords. It explains that there is an irregular and round mass present inside the liver. Also, as a characteristic of this mass, it has a slower propagation speed than the liver tissue. You can see this as a pattern where you choose the corresponding ultrasonic phenomenon. Basically, for an ultrasonic phenomenon to occur, reflection can be involved. Also, as you go deeper, attenuation of the image occurs, so absorption can also appear. In the next sentence, you can see the expression irregular. In such cases, scattering may occur, and at the edge of a rounded mass, refraction can also be observed. The correct answer would be to choose the option that includes all of these. Let's move on and look at the next question. Since this question follows a pattern we've already solved earlier, let's go straight to the answer. For the option related to strong attenuation, you can select shadowing as shown in option 10. When encountering solid structures such as stone, strong attenuation can occur behind them, resulting in shadowing. Let's scroll down and look at the next question. Question 103 contains many expressions that are not particularly relevant to the SPR exam, so we'll skip this one without solving it. It's not an especially important topic either. Since there aren't any elements likely to appear on the exam, let's move on to question 104. If you look at question 104, the content is a bit long. But ultimately, what it's asking is what kind of physical phenomena occur when encountering irregular structures. So you can choose scattering, which is answer choice number 2. Even if you're not very familiar with English, as long as you know the related concepts and the associated keywords or terms, if you just know the terminology related to ultrasound, I can say that solving the problems isn't particularly difficult. With that, we've solved up to question 104. Let's move on and proceed with solving the problems in the next chapter. From here, I'll be explaining content related to ultrasound transducers. Before we dive into solving the problems in earnest, let me explain how the explanations will be structured. The problems we've solved up to number 104 were about the most basic concepts and principles of ultrasound, which correspond to Module 1. I can say that this was the easiest part compared to the others. Even without a theoretical background, you could grasp the content to some extent just by solving the problems, so I can also say that this was such a section. On the other hand, the material we'll be covering from now on consists of problems that belong to the second module. The sections here have the characteristic that without knowing the basic concepts, you cannot proceed with solving the problems. Since it would take too much time and be inefficient to explain all the concepts in this problem-solving lecture, I will proceed with the assumption that you already know the basic concepts. Therefore, if you find that you do not fully understand a concept while listening to the lecture, I strongly recommend that you review the theory again before continuing with the problem-solving lecture. Alright, based on this premise, let's solve the problems one by one. Looking at problem number 105, it's a question related to resonance frequency. Since there is no difference from the correct answer in this problem, I will not go through the solution separately. Instead, I will explain the concept to you. If you look at the related diagram, the most representative factor that determines the resonance frequency is the thickness of the crystal. If the crystal is thick, the resonance frequency above will be formed at a lower frequency. On the other hand, if the thickness is thin, it will be formed at a higher frequency. The most important thing to be careful about is the resonance frequency, which is also called the resonant or natural frequency. You should note that the frequency here is a different concept from the frequency we usually know. If you study both as the same concept, you might get confused later when you get into SPL. So, although the terms are similar, I want to emphasize that remembering them as separate concepts will help you when solving problems. The main point here is that it is related to the thickness of the crystal, so just remember this key point. Now let's move on and look at question 106. Question 106 is an important one that always appears at least once, so I want to emphasize it first. When the term bandwidth appears in a question, it's helpful to remember it by drawing two types of diagrams. First, you can think of a narrow type of bandwidth like this, and second, a wide type. So as long as you remember the difference between these two, narrow and wide bandwidth, you'll be able to solve related questions easily. In the narrow range, the resonance frequency can be measured as higher. Let me emphasize once again that this concept is different from the frequency we are familiar with. Next, the SPL here is connected for a long duration. So a characteristic of SPL is that it is long. The wide bandwidth here is the opposite of this. The frequency can be measured as lower. As for the resonance frequency, on the other hand, SPL has the characteristic of appearing briefly like this. The fact that SPL is long can be understood as meaning that the axial resolution is lower. Conversely, if the SPL is short, it is related to the concept of increased axial resolution. The correlation here is always included in the exam. And please also make sure to understand what differences exist in the bandwidth. Since the question is asking about a broad aspect, you can consider it as being related to this topic. If you look at the answer choices, it is asking what advantages a wider one has compared to a narrower one. The main advantage is that, because the SPL is short, the axial resolution is better as a result. This is the most significant feature. Therefore, you can choose option B as the correct answer. Please review the overall concept once again using the diagram shown here. Let's move on and look at the next question. Like question 106, this is also a question related to bandwidth. This is a question where you need to choose the pulse length associated with the given diagram. Let's take a look at the diagram right away. This is the type with a wide bandwidth, as shown in the diagram we just drew. I mentioned that this kind of form results in a short SPL. If you look at the options, you should choose the shortest one, option C, as the correct answer. This was a problem you could easily solve as long as you knew the basic concepts. Let's move on and look at the next question. Looking at the question, it says that a thyroid ultrasound is about to be performed and they want to set a long near field. So this is a question asking which probe should be selected. First, since it's a thyroid ultrasound, you need to choose a high frequency. Next, to make the near field longer, you need to select a probe with a larger diameter. So, through this question, you can organize the two factors that affect the near field. You should remember that as the frequency increases or as the transducer diameter becomes larger, the near field increases. Since this question is also important, I want to emphasize it. Next, let's move on and look at question 109. If you look at the question, it's related to lateral resolution. This is one of the most important concepts covered in the SPR exam. You should consider that anything with the term resolution at the end is important for the exam. So, I want to emphasize this question as well. This question asks you to choose the option that can improve lateral resolution. Looking at option A, increasing damping is a concept related to axial resolution. In option C, bandwidth is also a keyword associated with axial resolution. As for option B, decreasing frequency lowers both types of resolution, so it can be considered an incorrect choice. Therefore, I will exclude options A, B, and C. Next, looking at option D, the term aperture refers to the opening, and when this aperture decreases, the beam tends to spread out more widely. This causes a decrease in lateral resolution, so option D can also be excluded. Yes, the correct answer would be option E. When a curved crystal is used, focusing becomes possible. Focusing plays a significant role in improving lateral resolution. For related terms like axial and lateral, it's also necessary to understand their definitions. You should organize and review which factors influence them, either through solving problems or by summarizing the theory. Let's move on and look at the next question. This question is about asking related terminology. In the context of focusing, there are specific names for each region where the beam converges and diverges. I want to emphasize once again that this is a concept you definitely need to organize and understand. In the question, it asked about the narrowest region of the sound beam. The correct answer is the focal zone. You can select this one.